The Model 2 line is finally here, and it's breaking physics. Tesla just fired up production at Giga, Texas, assembling complete vehicles in 19 seconds, while Toyota's Corolla takes 57. Leaked supplier data shows 189 cars per hour, 50,000-ton Giga presses replacing 70 parts with single aluminum castings, and AI correcting defects in milliseconds. But here's what nobody saw coming: the price. How does Tesla hit $10,597 without sacrificing quality? Is this the kill shot for legacy automakers still welding the old way? Let's dive right in. Here's what's actually happening on the factory floor right now. Leaked drone footage from suppliers near Giga, Texas, shows two parallel assembly tunnels running simultaneously, each spitting out complete vehicle bodies every 38 seconds combined. That's 189 cars per hour, 1,512 per shift, over 1 million annually, with just 14-hour days and 6-day weeks. Toyota's legendary Corolla line, 57 seconds per car. Tesla just tripled the industry standard. But speed means nothing if the cars fall apart, right? Wrong. The tolerance data tells a different story. Laser-guided optical calibration checks 1,200 reference points per vehicle in real time, maintaining precision within 0.2 millimeters. Aerospace-level accuracy. Traditional quality control happens at the end of the line. Tesla's AI corrects misalignments as they occur, merging inspection into production itself. So the question isn't whether Tesla can build fast. It's whether anyone else can catch up before the Model 2 floods the market. Let's talk about what makes this physically possible. Traditional automotive presses operate between 2,000 to 6,000 tons of clamping force. Tesla's new Giga presses? 50,000 tons. That's not an incremental upgrade. It's a categorical shift in what die casting can achieve. With that kind of force, Tesla can cast single-piece structures measuring 6.5 feet in length with wall thickness down to 0.08 inches. Here's where it gets wild. One rear underbody casting replaces 70 individual stamped metal parts. 70. That means no welding those parts together, no quality checks on each piece, no storage logistics, no potential failure points from hundreds of fasteners. Industry insiders estimate this approach cuts body shop floor space by 30% and slashes assembly time from 6 to 7 hours down to under 90 minutes. The cost savings? Between $1,100 to $1,400 per vehicle just from casting alone. But there's a catch nobody's talking about. These Giga presses sit just 150 feet from the main assembly line. Why does that matter? Because Tesla transports freshly cast components while they're still over 300 degrees Fahrenheit, using residual heat for thermal fitting, a technique borrowed from aerospace. Parts expand during installation and contract as they cool, creating tolerances tighter than cold assembly could ever achieve. The entire factory layout is designed around heat, timing, and physics. This isn't car manufacturing anymore. It's precision engineering at scale. Since Henry Ford's Model T, every automaker has followed the same blueprint. Separate the body shop from the paint shop from final assembly. Different buildings, different environments, isolated processes. Tesla just deleted that entire concept. Welcome to the unboxed line. No walls, no barriers, no dedicated buildings for each stage. Instead of isolating entire facilities, Tesla creates micro-environments around specific operations. Laser welding happens inside portable clean chambers that move with the vehicle. Paint application uses compact mobile electrostatic booths. Battery installation occurs in climate-controlled pods maintaining humidity below 15%. The vehicle flows continuously through the factory without stopping for environmental transitions, a design that could reduce total assembly time by 22% to 28%, according to industrial engineering models. Here's the part that sounds impossible: battery pack integration. The Model 2's 2,170-cell battery pack weighs 850 kilograms. On BMW's II3 and i4 lines, battery installation requires separate stations taking 12 to 15 minutes per pack. Tesla's synchronized robotic arms handled the entire 850 kilograms in a single motion with sub-millimeter accuracy, completing installation in under 90 seconds. How? AI-driven conveyor control, where robotic arms communicate directly with each other, adjusting movement in milliseconds based on camera feedback. The system is called Autoline OS internally, and it's monitoring over 2,000 data points per vehicle: paint viscosity, torque on battery bolts, thermal expansion rates, robotic arm positioning. Any anomaly triggers automatic line adjustments within 2 seconds. No human intervention, no stopping production. The line behaves like a single adaptive organism, not 300 isolated robots fighting each other. Now we hit the part that breaks people's brains. How does Tesla deliver a fully electric vehicle for $10,597 without cutting corners? The math actually works when you break it down, but it requires accepting that everything we thought about car economics is about to change. Start with Giga casting savings, $1,100 to $1,400 per vehicle. Add battery cost reduction through bulk procurement and automated installation, cutting 12 labor hours per 1,000 vehicles produced. Tesla reportedly locked in aluminum supply contracts at 82 cents per pound for the next 5 years, 18% below current market rates for aerospace-grade material. Battery cells? Volume-based pricing drops the per-cell cost by 12 cents for every 100,000 units beyond 5 million cells annually. At Model 2's projected volume, Tesla hits that threshold in the first 4 months. Then there's the electronics strategy. Instead of the full sensor suite from Model S or X, the Model 2 uses a streamlined AI module delivering essential autopilot features while cutting hardware costs by roughly $1,000 per vehicle. Software and essential features stay intact. The expensive sensors? Gone. That's not corner cutting, that's strategic cost engineering. But the real breakthrough is the 19-second cycle itself. Every second saved on the production floor cuts costs in power consumption, labor overhead, and equipment depreciation. Reducing idle time by 65% compared to Giga Shanghai's Model 3 line means the factory runs at 95% uptime. Fewer interruptions for maintenance, fewer operators per line, lower energy costs per vehicle. The economics compound. Tesla claims this system could save $350 to $400 per vehicle annually, just from logistics alone. Minimized internal transport, reduced storage, optimized floor space. Add it all up: casting savings, battery procurement, automation efficiency, streamlined electronics, and logistics optimization. You're looking at total cost reductions exceeding $4,000 per vehicle compared to Model 3 production costs. Here's what this actually means in practice. If Tesla maintains these numbers, and the leaked supplier contract suggests they're serious, the Model 2 could hit U.S. markets at a price point that makes the Corolla, Civic, and Camry look overpriced. We're talking about an EV cheaper than most gas-powered sedans, with lower operating costs, better performance, and autopilot as standard. Legacy automakers are still stamping hundreds of individual parts, welding them together in isolated facilities and moving vehicles through multi-day assembly processes. Tesla's doing it in 19 seconds per unit with higher precision. The gap isn't closing, it's widening. And here's the uncomfortable truth. You can't retrofit a traditional factory with this technology. The entire layout, the Giga press placement, the thermal fitting logistics, the AI synchronization, it only works as an integrated system. So what happens when 1 million Model 2s hit the roads annually at sub-$11,000 pricing? Does the affordable sedan market collapse? Do traditional automakers abandon internal combustion faster than planned? Or does someone find a way to compete with Tesla's manufacturing efficiency? Drop a comment if you think legacy automakers can adapt, or if Tesla's about to dominate the affordable EV market for the next decade. So here's what this really means. The $10,597 price point isn't just about affordability. It's about making gasoline cars obsolete. When Tesla delivers electric performance, autopilot, and lower operating costs for less than a Corolla, the entire value proposition of internal combustion collapses. That's the answer. Not through regulation or environmental pressure, but pure economic reality. And the 19-second cycle? That's not the end point, it's the foundation. If Tesla streamlines Model 2 production this aggressively, what comes next? Model 3 and Y lines with similar automation. Cybertruck production accelerated. Optimus robot factories using these same AI principles. This manufacturing philosophy scales across everything Tesla builds. Legacy automakers have maybe 18 months before Model 2s hit U.S. roads. That's not enough time to redesign factories, retrain workforces, or renegotiate supply chains. The gap is widening. This is Tech Revolution, where we break down the innovations reshaping industries before the mainstream notices. If you want this level of analysis on Tesla's next moves and what's coming from Giga Mexico, you know where to find us. The question isn't whether affordable EVs are the future. It's whether you're ready for that future to arrive faster than predicted. Does Tesla dominate the next decade? Or can someone challenge this production advantage? Drop your thoughts below. The revolution isn't coming. It's already running at 189 cars per hour. Tesla's Model 2 butterfly door just did something nobody expected. During rain tests, engineers discovered the angled design deflects 80% of precipitation away from passengers. Double the protection of Model X's gull-wing doors that let 40% splash right onto you. The geometry creates an instant umbrella effect. But here's the twist. This wasn't even intentional. The door was designed for senior accessibility with 60-centimeter side clearance, and the weather protection emerged as an accidental bonus. Could this solve the problem every driver faces but never talks about? Let's dive right in. Let's talk about those numbers. During Seattle testing, Tesla engineers measured rainfall deflection at different door angles. Traditional sedan doors, 15% protection. Model X gull wings, barely 60%. The Model 2's butterfly system hit 80% in light rain and 75% in heavy downpours. The secret lies in the 75-degree opening angle combined with the upward-outward swing that creates a natural water diversion path. But here's what makes this controversial. This feature emerged purely by accident while solving a completely different problem. The original target was senior accessibility. Tesla surveyed drivers over 60 who complained about three specific pain points: low